I'm here with Dr. Venkat Subramaniam, and we would be very interested in his take, in your take, in programming in general. So Venkat, what do you think about, what is your take on programming in general and about functional programming?
Well, first of all, thanks for having me here. It's a pleasure to talk to you and to your listeners. So programming is something that is life to me in a lot of ways. I've programmed for a few decades now, and oftentimes people ask, how come you're a programmer of all these years? And much like a lot of people, I got into programming because of the science and the math. That's as an engineer, that's what I wanted to do. But over the years, what really kept me as a programmer is actually the art in programming, which is really beautiful, because if you ask somebody to write a poem, maybe a love song maybe, well, there's no one poem to write. You could write infinite number of poems. In a lot of ways, writing code is like that. You could be writing code in so many ways, doing exactly the same result, but there are so many ways to do it. And that's one of the reasons why I really like functional programming actually, is because that is a very different form of expression. And it is very concise, it is something that is very expressive, it is elegant, and it conveys the idea without dragging you into the details. It's, in a way, if you really think about it, I say that imperative style of programming, almost all the mainstream languages for decades have been promoting imperative style of programming. Imperative style of programming, it really is loaded with accidental complexity. So when we start programming in imperative style, as we have done for a few decades, we are really going through a lot more effort to do the same work compared to functional programming, which removes a lot of these accidental complexities. And so it's the art form in programming combined with the ability to convey the idea to make the machine do what it's supposed to do is what really excites me in programming.
Yeah, you compared it to poems, where usually people have to understand their own meaning, but I hope that functional programming to you is more than that people should understand the same concept.
We have to understand the concept, but also though, it is a way for you to express. There's not going to be one way to express it.
Yeah.
And even in functional programming, one of the things we have to be careful is, there is no one way to write the code, even in functional programming. If two people sit down and write the code in functional style, it doesn't mean it will end up with the same code. And still there is this form of expression even in that as well.
Yeah. I noticed in many of your tweets that you talk about your intuitions of code, not necessarily, you don't subscribe, as far as I understood, that people, if people follow several instructions, then they will get to a better understanding, to a better use, and that you optimize mostly for testability, for maintainability, and not necessarily speed, expressiveness also.
So one of the biggest challenges that we deal with is when you are dealing with any complex system, if you really, one of the things we have all come to agree upon is that change is the only constant. Heraclitus said that change is the only constant in life, but that's so true of programming. And the minute we write a software, the next thing we want to do is to change it. But one of the biggest challenges is software is a non-linear system. You change something here, something would break over there. And we all like creating stuff, but I would rather create something that actually works. And I have a very strong desire to think about and improve the economics of software. I want to create stuff, but I also want to create stuff that is in a sustainable way. And that's one of the reasons why I'm a real big fan of going through automated testing, is because it gives me a very rapid feedback that what worked yesterday continues to work today. And when I have that, so to say, covering my back, I can go more wild and be creative and try new ideas. And just to give you an example, this happens quite often. I was teaching a class today, and we had automated tests already. And then we were writing code to pass those tests.
Mm-hmm.
And I implemented a solution And one of the developers in the class said, oh, wait a minute, you could actually write this in a slightly better way, a different way. Rather than arguing about it, I immediately changed the code to the extent that he said. And the minute I changed the code, the test ended up passing again. So we immediately looked at each other and said, hey, good idea, good suggestion. And it's a good feedback because he immediately gets the feedback that his idea is actually not a bad one. It actually works. How often people say, we can do this, and then we immediately say, well, would it work? Or if it works, it's a great idea. You don't have to guess. You can know that it's working right away. And to me, that is extremely positive. And I've seen this in several cases. Somebody would come to me and say, how about trying this? Well, no, we don't have to guess. Let's go try it. And if it fails, the test is going to tell us. And if it passes, the test tells us that too. I think that's really valuable, and that's what excites me. The other thing to be important is, I pay for software I create these days. I run a company where I have to pay for the software. I'm the developer, but I'm also the person who is sponsoring these projects. And to me, the time and effort put into creating code is extremely valuable. And then I find that there's errors and bugs. I don't have the luxury of coming back and fixing the code. It has to be very cost effective. And that's one of the reasons I would rather build fewer features with better quality than more features with poor quality. And I think that is extremely important.
Yeah, I agree. Would it be possible for us to go into that direction of how do you think people should start programming in general? Maybe kids. How should kids be taught programming at all? If yes, then should it be functional from start? Should it be TDD from start, Agile? Should non-programmers learn to program as a hobby? What is your opinion about that?
So it has been an amazing experience for me to watch children learn. But we got to keep one thing in mind. When it comes to learning, we cannot compete with the children. Because as an adult, we have to put in effort to learn. Learning is a way of life for children. They learn continuously every single day. And what is important is not that we have to put effort to help them to learn, but it's important for them to learn the right things, the right things to do. Attitude, caring about, to have the passion is the first thing. But then once they have the passion, to divert that passion into a creativity where they can produce value, but in a sustainable manner. That's very important too. When my son learned to write code on one of the projects he worked on, every single piece of code he wrote was automated and tested. And that's the only way he did it. And I told him, I'm not going to sit here and write the code for you. I'm going to teach you the basics and walk away. And you are going to go build the application yourself. And he did. And he wrote automated tests and built the entire application that he built with automated testing. When I teach kids these days, in Java 1 for kids or DevOps for kids, I actually give them automated tests. And then I tell them to write code to make those automated tests pass. And some of the kids come back and the parents come back and say, it's actually pretty amazing to do something and see it actually work and then see the results. But what's important is when I teach the kids, I ask them, how many of you would like to create something? They all kind of raise the hand. And then I say, how many of you would like to see it actually work? And they're as eager to do it. So I do believe that it's important to teach them a sense of quality. It's important to teach them a sense of feedback loops. You want to know that things actually you create are actually working. And they quickly realize that what they type is not going to work all the time. Our human brain is extremely capable, very intelligent, but the error is human. So the point that I want to really bring out is we are really good, but we got to bring in things that compensate for where we are not good. Yeah. As humans, we are creative, but we are also very error prone. So we want things to help us. So for example, you cannot remember every single meeting you have to attend. That's why you have calendars, that you have your reminders. Same thing with coding. We cannot remember every possible permutation and combination. That's why we have automated tests to tell us when things don't work. And that's something we need to really inculcate in them and say, you are smart, you are capable, but there are things you won't be able to do as a human, and there are tools for you to leverage And I think that's extremely important for us to be able to teach them that. But one of the other things that's been fascinating to me is to really help them learn without pushing them towards jargons. And when you push people to jargons, the value is lost with jargons. So, and I improvise a lot, and I try to learn along the way. It's fascinating when that happens. So my most recent experience was, I was teaching JavaScript for children. And one of the child in the session said, what's Node? So suddenly, what's Node? How do you describe to a 8-year-old what a node is? And I thought about it for a second, and I said, okay, how many of you here play music? And in the entire room, there was 100 to 150 kids in the room. The entire room hand goes up. And I said, well, you know what? I don't know to play music. I'm a failed student of music. I went to my teacher and I said, teach me music. And within a day, the teacher said, you're a complicated man, leave. Because everything the teacher would say, I would immediately relate to programming. But there was one aha moment for me in that little experience. And that is, when you have a music script in front of you, and you look at the script, and then you play your piano, and so what do? You read the script, and then you're pressing these keys, and the piano makes this beautiful music. And I said, as a person playing music, your job is to read the script, and then make this machine do stuff.
Interpret it.
Interpret it, right? Without using the word interpret. And your job as a musician is to read the music script and make the machine move the parts of the machine. Well, that's exactly what Node is. Node reads the script, in this case, JavaScript, and then moves the parts of the machine so that the machine can do whatever you ask it to do. And it was like a snap. And the kid is like, oh, okay, that makes sense. And I think that is the key, is to really bring it down where they can actually appreciate and realize this is not really hard stuff. It can be a fun stuff to work with. And so to keep the jargons away, to make them feel that this is something that's going to be part of their life and they can actually do it. And it can be fun doing it, I think is extremely important.
Thank you. What do you think the importance of functional programming is in this area? So should kids be taught functional from start, or maybe just shapes, arranging shapes in different ways, or directly in a programming language as adults do?
I think the first thing is the kids should learn about problem solving. I think we are going in the wrong direction if we focus heavily on programming alone. Because if you really think about it, what do you and I do as an adult? Well, we program, but that's not what we really do. At some point, we begin to realize programming is only a small part of what we do. The major part of what we do every single day is problem solving. Right? When I walk into a client site, when I walk into a room where they're talking about something is not working, we have a performance problem in production, or we have a bug in production, or we have a failure of a system in production. How do you fix it? And your ability to understand the problem, analyze it, and then come with a solution is what really counts. So while programming is a vehicle, a tool, we have to really help them to learn about problem solving. And I think that's one of the key parts we need to really help the children is get really comfortable solving problems. Programming is one way we can solve certain problems, but there are other ways to solve the problems too. And I think we shouldn't lose the sight of that. So we should really help them to learn problem solving. But the other thing too important also is, one of the key things to really teach the children very early on is this notion there's not one single way to do things. Because one of the things we find adult programmers get hung up with is they feel that there's one language, one solution, one way to do things. And if you really look at programmers who are a little bit better than others, what do? They are open to ideas, open to suggestions, open to look at other solutions, right? So one of the things I actually do, I teach at the university as well. So they're not kids as in children, but they're not also grown-up adults. Not all of them are, some of them are. But a lot of these people they've finished high school, they are into their second year or third year of college, they don't have a full experience in the industry. But one of the things I really try to help them see is, I want you to learn 3, 4, 5 different programming languages. So when you come out of the course, I want you to know there is no one way to do things. So when a problem is given to you, I want you to openly think about 3 or 4 different solutions. I think that's what I would be really aiming for children as well. So that they realize that when given a problem, they have to be open at looking at multiple solutions, multiple avenues for the solution, and not be convinced that whether it's functional programming or imperative style programming or dynamic type language or static type language, I don't want them to, dig themselves in a hole and say, this is the only way to do things. It's really too early for them to explore one thing and say, I found my answer. It is a time for them to explore and figure out and see that there are actually multiple ways, and let their mind grow into thinking in a diverse set of knowledge. There is a very old research called cipher-word hypothesis. This was intriguing for me. The cipher-word hypothesis is about natural languages. And what they are saying is, as a human, what we think is greatly influenced by the languages we speak. And the fewer languages we speak, the more limiting it is. For most of us, I would say, non-English native speakers, it's already given.
Yeah.
My mother tongue is not English, your mother tongue is not English, but we speak English as part of speaking yet another language. We already are focused on knowing more than one language. And what they are saying is, the languages you know actually influence what you think. This was intriguing because I always thought that what I speak is my thoughts. But they're saying what I'm thinking is related to the language I know. But I can attest to this. I'm not a language specialist by any means. But I can definitely attest to it, that in programming languages, the design that I can think about is greatly influenced by the languages, the programming languages I know. I used to know only one language once upon a time, and I frown upon myself looking back. And when I started learning other languages, it was eye-opening. It's like, wow, these are the design ideas I never even thought exist, because the language I programmed, it never gave me that thought process, right? So knowing these different languages expands your design. And we cannot deprive the children of doing that. When the children go and experience multiple languages, they begin to realize there are different design capabilities, and they realize, oh, I cannot do this here, but I can do it here. I cannot do this here, but I can do it here. And then they realize, oh wait, when a problem is posed, I should really consider what these options are, and then maybe I will select a language or a library or a tool based on the problem than being limited by only thing I know. To really give them that moment is the most important thing. And to me as a teacher, it would be really unfair if I try to drive them in one direction. But it used to really give them the tool, give them the mindset that there are these different options, you got to explore those. I think is extremely important.
Could you tell us examples for these different languages? How would you advertise different languages? Guys, you should try, for example, Haskell. I know you're scared because it's an ivory tower, a language that only academia is using. But let's try it and try it for yourself, and you can see that it might not be. Or maybe Clojure. Ooh, it's dynamic. It's a Lisp. How would you convince people to try these out and that, for example, not Java or JavaScript is the only way to go?
When you're exploring a certain concept or an idea, you want to kind of go back to the roots. So,
different languages. Guys, you should try, for example, Haskell. I know you're scared because it's an ivory tower, a language that only academia is using. But let's try it and try it for yourself, and you can see that it might not be. Or maybe Clojure. Ooh, it's dynamic. It's a Lisp. How would you convince people to try these out and that, for example, not Java or JavaScript is the only way to go?
When you're exploring a certain concept or an idea, you want to kind of go back to the roots. So, this is funny, but I'll be in a room and I'll be talking about a particular language feature. And I would have people come to me and say, oh, that feature is like in Scala. And that would make me laugh. And so why do you say it's like in Scala? Oh, because I've used Scala. I've seen this one. So it's like in Scala. Well, and then in the same token, another person in the room would say, that's like in C#, or that's like in Ruby. And it turns out, we always gravitate towards what we know. That's all we can do. But once you look around, you realize there have been languages before these languages, and these languages have had it. And when you want to learn a particular concept, you want to go to a language which does it well, really well. And to me, that learning experience was, so let me put it this way. Why should I learn a language? Maybe even an esoteric language. And the reason simply is, if I know different languages, the time I need to learn a new language is actually less. So in other words, this is like your physical muscle, right? If I'm sitting on my couch and eating potato chips and drinking Coke and watch TV for 8 hours a day, and I put on weight, and you come to me one day and say, want to go for jogging? I'm like, jogging? Why don't you just get me more chips, and then you go for an extra jog for me, right? I won't be able to respond when my body, the muscle, has not been exercised. It's the same thing with the mental muscle. When my mental muscle has become lethargic, I've driven myself in my comfort zone. I keep doing what I'm comfortable with. When a new thing is thrown at me, my mind doesn't respond to it. My mind says, go away, leave me alone. But on the other hand, I go explore different things, new things, something that is completely different from what I do, what I know. My mental muscle is constantly active. When my mental muscle is constantly active, when you come to me at work and say, hey, we got a need to do this for a client, can you go explore this? Well, my mind has been active all the time. I can't pick it up very quickly. So to give you an example, learning is not easy. It takes a lot of time. And I would be really doing this disservice if I tell people I can learn things quickly. It's actually not true. I actually need a lot of time to learn. But having said that, it took me two days to learn Groovy. You're like, wow, you're smart. You took 2 days to learn Groovy. No, actually not. I'm not smart at all. I'm the dumbest person I know personally. But I had been programming in Ruby for a few years at that time. And when I had to learn Groovy, all I had to do was ask the question, how is Groovy different from Ruby?
Or Java.
Or any other language. When C# introduced the yield keyword, people were like, oh my gosh, what is yield? And my question was, how is yield in C# different from yield in Ruby? Because I've used yield in Ruby, and I want to know, hey, these are generators. JavaScript recently introduced generators, and you have a yield keyword in there. And you're like, hey, how is this yield in JavaScript different from yield in C# and yield in Ruby? Well, you see how Ruby is so different from C#, which is so different from JavaScript, but you're able to relate these ideas. Your learning becomes so fast when you do that. I had been programming Erlang for a few years for absolutely no good reason. I heard about Erlang and I said, I gotta know this. So I started programming in Erlang. I have written a production system in Erlang? No, I've not. I've never written a production system in Erlang. But I wanted to learn Erlang. But then I had to learn Scala very quickly. But I had to say, hey, Scala has actors, Erlang has actors, but keep in mind, Erlang is a dynamically typed language. Scala is a statically typed language, but it doesn't matter. There's an actor in both, but I ended up learning Scala very quickly because I did not have to learn what actor is, because I've taken the time to learn that when I was learning Erlang. But now, so the point really is, we learn in deltas. We do not learn in huge chunks, we learn in delta. So if I had taken the time to learn this language, then my mind is always doing this delta. Hey, you know this one is different, I can learn it. Well, now it's kind of like climbing a stair. I've climbed this one stair, the second stair, the fourth stair, and suddenly I'm on the 5th floor. You ask me to come to the 6th floor, I don't have to climb that far. I'm already on the 5th, I can come to the 6th floor. And this is why learning different languages continuously is very important. I tweeted this a few years ago. I was in a class, there were 2 people in the class. They both are about the same age, working together, about the same background. But one person has been learning different languages. The other person has been programming in only one language. When I was teaching and introduce a concept, one person would say, why? Why are you bothering me with these? This is so different, it's hurting my head. The guy next to him would say, oh, wait. Come back to that. Can you compare this, how this works in Okama? Can you compare this to how this works in this other language? And this person was like a sponge absorbing things and always wanted to compare. It was fascinating. So I tweeted saying, the time it takes you to learn a new language is inversely proportional to the number of languages you know. If you know only one language, and you want to learn a completely different language, you need maybe a year, 2 years, 3 years. But if you know 10 languages, you probably would learn that other language in a month or a few weeks. And that is one of the biggest benefits. So to answer your question, what's the motivation for me to learn something different? Well, you end up learning things very quickly the more you know, the more diverse your knowledge is. And it expands your design skills. It expands your ability to go and explore. It keeps your mental muscle active. And that's, pragmatic programmers say, you got to learn a new language every year. Well, learning a very different new language every year is extremely important. But forget about year. Constantly learn a different language. Master it. Move on. Pick up the next language and keep learning it. That's I think is extremely important.
Yeah, I fully agree. How would you convince people who don't really see the need for a new language? You said it leads to being able to learn new languages more quickly, but if people say, well, I already have enough problems in production, and I'm already using a given programming language because the company will not let me use another one, why should I learn another language?
2 answers. But I'll start with the second one first. The company wouldn't let me use another language. I will reflect back on my career. In every single company that I worked in, the language they programmed in was not the language or the environment my next job was in. So it is really to make myself valuable, right? But at the end of the day, while I produce value, give results to companies, I've got to build my career too, right? And always I say this, when I come into a job, they have to benefit from me, but I've got to benefit too. And there's only so much you can benefit from the company. You're producing results in the environment you're working in. When I worked on a job which required C++, and I looked around and said, oh look, there's this new language called Java, back in time. But my company is not going to abandon C++ and start programming in Java overnight. That's not going to happen. But people are talking about Java. What do I do? So I said, you know what? This is what we're going to do. I'll come to work. I will work in C++ because that's my day job. But I'm going to go to home in the evening and I'm going to spend an hour, maybe late in the evening, maybe early in the morning, a Saturday morning, and I'm going to learn Java. And I'm going to use this language, learn about it. And when you do, well, then you see there's a job opening that requires this other language. Or your own company comes to you and says, we're thinking of using this other language as the other project. We're looking for people. Hey, I know something about this. It makes you more valuable in the company, right? That's one of the reasons. But the second reason is, you could be working in this job and you're always trying to deliver results for what you do. And I already have these troubles, why should I do anything more? Well, this is where the word professional comes in. There is a difference between, if you look at lawyers, doctors, these are called professionals. Imagine you go to a doctor and the doctor says, you know what, I know the medicines I'm using. I'm going to treat you with the medicines I know. Don't bother me with these new medicines. I already have enough things to do. Well, that is not going to be a good doctor for you. A really good doctor not only gives you the medicines that's well proven, but he's also willing to say, hey, here's a new medicine in the market. it's been approved by the FDA, but I want to help you with that medicine. That's where the doctor is valuable to you. You want your doctor to say, here are some new tools that are in the market that help with this particular pain, we should try it. I was sick, and I went to the doctor, and the doctor said, oh, we could do surgery. I'm like, no. I don't want surgery. What are the other alternatives? Don't worry about it. We do surgery, it'll be better. And then look at the form, threatening. You may die because of the surgery. It's like, are you serious? I have to sign this? Yeah, it's legal, you got to sign it. You may be paralyzed when you do the surgery. You might lose this and that and that. This doesn't give me comfort. The effect of your surgery seems to be more damaging than the problem you're trying to solve. Can you please discuss alternatives to me? And that was not done. And that really frustrated me. And then I went to another doctor and they said, have you tried these things before you considered surgery? I was like, oh my gosh, I didn't even know these things exist, right? I'm the novice, I'm the patient, but I want the doctors to give me that option. Well, in my job, I am that professional. So when my company says, solve this problem, it's for me to come back and say, hey, here are the solutions. Imagine, so I'll give you an example of this. Very, very proven example. Just exactly this one. So I had a company call me and said, come train my team on this particular technology. So I go there to do the training. And when I went there to do the training, the manager who invited me said, Venkat, do you know why you are here? I said, well, I'm here to obviously do the training, but no, I don't know what brought me here. I said, that's the first thing we should do, so come with me. And before the class starts, there's a room here full of developers waiting for you to start the class, but I want you to come with me before that. And he takes me to this other room. And there are two developers sitting there and coding. He says, these two guys are the reason why you're here. I said, well, what's going on? Well, these two guys are developers in our system. This is a very highly complicated system with millions of users in the market. So very high demand on concurrency, right? You can imagine millions of users in the market use this application, very high demand on concurrency. And he said, we've been developing this application, concurrent application, for a few years now. These two developers saw your talk. And they looked at what you talked and they said, whoa, that technology addresses concurrency in a lot better way. They came back to work, and over a 2-week period, they did a prototype. And they developed a prototype with this. And then they came to the rest of the team and said, hey guys, you can continue to develop code using this concurrent solution. Everywhere you turn, there's lock and synchronize and deadlocks and live locks, right? You can go on, keep doing it. Or, we took this module and re-implemented it. There is no locks in this. There's no concurrency issue in it. So here you go. You can either continue to do what you guys do, or you can do this. It's up to you. So we evaluated it, and it was clearly the sign that we are not going to succeed in what we do by doing what we are already doing. And we got to change direction. And so we did evaluate it. We went through it. Took us a few months, and that's why you're here. To train the entire team, because we have decided to change direction. And these two guys are the ones who did this for us. And they would not have done that had they not taken the time, A, to learn it, and B, to go give it a try. And now they are completely turning their team into a different direction for the better, right? We want to be those leaders. We want to be those professionals. We want to be the people who come with better solutions. How could we possibly do that without being professionals, meaning learn, apply, and evolve?
Yes, yeah.
We have to.
How often do you see that companies are willing to abandon work that they have done previously in favor of upgrading to a newer paradigm, maybe?
It is not too common, but it's not unusual also. One of the problems with we engineers, programmers, technical people, is we speak technology. It's not going to help us. You and I should geek out, talk about technology. But at the end of the day, we must be able to convince the business why it's better for the business. When you go to the business, the wrong things to tell the business is, this technology is cool. right? They don't understand. In fact, they are scared. They're going to say a bunch of kids are going to get together and they're going to do something, and these geeks keep them away, right? We have to go to them and speak in terms they understand. So go to them and say, what's the value? Why should you use this? Not because it's a cool technology. How does it affect their bottom line? Does it save them money? Does it get them faster to the market? Does it help them develop product with fewer errors in it? So speak in terms of business value. Well, people often say, how do I convince the company this is better? And I always ask the question, are you convinced? If you are not deeply convinced, you cannot convince other people. You know, when people say, how do I convince my boss TDD is important? How do I convince my boss using this other library is important? You convince.
Have you done your homework?
Have you done your homework? Have you worked on it? Have you created a prototype? Once you have done it, put it out in a way they can see the value, right? So in a way, we have to be salespeople as well, not just the technology people, right? So when I come to you, I should be able to give you a reason why this is better in ways that I can convince you. That's extremely important. And if I cannot convince you why this is better for your business, how could I then expect you to buy this, right? I think that is the key, is we have to really understand the value first and then find a way to make other people see the value in it. They don't care about the technology. You and I do, but they don't care about the technology. They care about the results, the benefit. So we need to be able to express it in that terms.
Yeah. You being a consultant, what is the problem that you see most often? What is the lowest hanging fruit that you see that is applicable usually in companies? What is the biggest problem that is solvable with the easiest, the least effort?
Well, I'm not the smartest guy at all. And like I said, I'm the dumbest guy I know. When I go into companies, and they would be very reluctant when I come in, because they've been having these problems. And they look at me and it's like, so you think you can come and solve the problem, huh? Right? And the programmers are agitated, right? Really angry a lot of times. My most recent experience was for a client in the northwest part of the country in the US. And I walk in, and the developers don't want to smile, don't want to shake my hand. They've been having this production issue for 6 months. And the manager says, you know, here's this guy, and very nicely done. He never introduced me, which is awesome, because they don't have a clue who I am, right? He says, oh, this guy Venkat is here, we're going to solve this problem. But they never heard of me, which makes it really well, right? And they're like, who are you? Why are you here? Yeah, I need to help you with this. Oh, you think you can come and solve the problem, huh? We've been trying this for 6 months. Hey, you know what? I'm not here to fight with you. But what do I know? You are the one working day and night, right? I'm just going to learn from you. I'm going to help you. So we sit there and we struggle. We struggle together, right? And they're getting angry because you're asking questions like, hey, let's take it easy. I'm the guy who doesn't know anything, right? Help me see this. Mm-hmm. At the end of the day, every project I've gone to help, there's one common theme that developers often don't do. But when I walk in, I'm able to do it not because I'm smarter. It's because I'm distancing myself from the problem, right? And that is, you have to isolate the problem from the surroundings. That is the lesson I've learned over the decades. You have to know how to isolate the problem from the surroundings. In this massive system, in this enterprise system, things are not working. You're frustrated. And you got to sit there and say, let me try to zero in on the problem. Is the problem here? No, it's not here. I can prove it's not here. Is the problem here? No, it's somewhere here. But let's zero in. So to be able to isolate the problem from the surrounding is the most important thing. And so one of the technique we have to develop as developers is how do you sift through these things and say, no need to work here, no need to work here, focus on this. And when you do, and when you isolate, and then you come up with these solutions, And then the developers go and try these solutions, come back and say, that idea didn't work, this idea didn't work, but here are two ideas that seems to work, but we have to focus more on. I think that is the key. The ability to isolate the problem from the surroundings. You know, in a system where we have automated testing, we've done that. We have tested at various levels. So you can run the test here. This test is working, but this level test is not working. Oh, so the problem is not here. The problem is between these two layers. I can think about it. But in systems where there's no automated testing, this is the strength that we need to have developers, right? Is to say, okay, let me start zeroing in and isolate different areas and zoom in. A lot of people don't isolate the problem from the surrounding. And they get dragged into the dependency, dragged into the complexity, and they're not able to think clearly and see where the things are. I think that's one skill I think we all have to take the time to learn and get better, is how do you isolate the problem from the surrounding? This goes back to what I was mentioning earlier. This is one of the reasons why we have to teach the children how to solve problems, right? Because that is what is so critical. In these production problems, it's not the programming language, it's not the library or the tool, it's the inability to solve the problem that really hurts us. And that is what I would say is very critical.
Yeah. You're an agile advocate, as far as I know. The consulting company is also about agile, as far as I know, and functional programming advocate also, as was recently. You had a talk recently here at Transylvania JUG. What would you say the advantages of these ideas are, these directions are, in relation to?
So this is a very important question to ask, because when companies adopt agile development, if they don't stop and ask, why are we doing it? How does this benefit us? Then we get into the ceremonies, the mechanics, rituals, and then we lose sight of why we actually started doing this. So if you look at the waterfall, what's the problem with waterfall? The problem with waterfall is there is no good enough feedback loops in it.
Exactly.
The time when you have gone through analysis, requirements gathering, analysis, design, and then you get to programming, and then people start programming, and then they get to testing. And when you get to the testing, you've spent so much time getting there, and you're so far into it, when something doesn't work, that moment is called a moment of panic, right? All you can say is, oh my gosh, what do? I don't have enough time now, and now I'm realizing that this is not working. Well, it's so late in the game that there's not much time to do anything about the panic we hit.
Yeah.
Well, it's the feedback loop that's most important. When companies get into agile development, they lose sight of it very quickly. They don't take the time to ask, what is it we're trying to do? To me, agile development is feedback-driven development. So it is to drive the development process using the feedback loops. When I go to companies and they say, I'm doing agile, and then they tell me, we have fixed the deadline, we have fixed the scope, but we are agile. You know, this is probably one of my most popular tweets ever in terms of retweets. I never expected this to be, 5,000, 6,000 retweets of this particular tweet. And the tweet basically said, I've set the wedding date, I have not asked her out yet. This is how software projects are managed,
yeah.
Right? And it's so true though, because we've decided everything, and now we want to be agile. No, the very first keyword is adaptive planning. If we're not doing adaptive planning, then what is there left to do agile, to be agile, right? So the point really is, we have to adapt our plan, what we do, based on the realities of the project, the realities of the world around us, the realities of what is changing around us. It is so important that we plan in agile development that we don't leave the plan to a big phase. We do active, adaptive planning. Every single day, we are looking at the plan. Every sprint, we are looking at the plan. Every release, we are looking at the plan. So we got to constantly adapt the plan. To be realistic, if I say, I want this result. I want this process. I'm not going to change anything. I have said everything I need. It's you guys who should change things. That's not agile. We can go around being happy saying the word agile. And I think that's one of the things people have to stop and ask themselves. Am I really developing in an agile mode? Or am I just using the word agile to feel good and going off and doing something completely different? Am I being adaptive? Or am I being adamant? Being adamant is not agile development. Being adaptive is. I think people lose sight of what this is, and then they complain they're not getting results. I think we should revisit what we do and become more realistic.
In your opinion, how can you solve this problem in the real world? If I'm
to grow
for example,
up.
yeah, but I can grow up, but still not.
No,
not
as an
especially-
industry.
Yeah, I agree with that. However, something concrete. If I'm a developer in a company and I'm the only one who wants to do agile. Everybody says we're doing Scrum, but you know the term Scrum, but
Right.
how can I be the change that requires this transformation?
The first I would say is to be non-threatening. People don't want to work with you if you're threatening, right? So first is to be non-threatening. When people see that you are really genuinely trying to improve, they are going to be more willing to work with us. That's the first thing. Second thing is to really help people grow up, meaning I was very fortunate, I would say. I never once had a boss, mostly, who said, you will do this. I'm your boss, I'm going to tell you what to do, and you're going to do it. It's always, some of the bosses I've had, I really respect, because I can always walk into their office and say, I don't understand this. I don't understand why we want to do this. If we do this, you're saying we're going to get this result, but here's why I think we're not going to get the result. Here's why we have to change it. It's not that they will agree and do everything I tell them to do, but it was very healthy to go and talk to them, to challenge them in a very healthy way, in a constructive way. And I think it's important to grow an organization where the culture is anybody can come and talk. If you look at Intel, the culture in Intel from the day one was you can walk up to the CEO and say, I don't agree. And to challenge, right? That's what makes a great organization, is to challenge everybody in the organization and say, we can do better. We got to question what we do. That's a culture we have to build. And in an organization to go and you want to recruit, as a change agent, you want to convince people why this change is good. And you start that with one person at a time. You think there's a better way to do. Sit down next to one of your colleagues and say, hey, let's try this. Let's explore this. And you're going to have people buy into it. Slowly, one person at a time. When you convince that one person, you have 100% growth already. Because it was you, but there's two people now. Now go find the third person. And slowly but surely change the minds. But showing them the benefit, right? People don't want to be told this is better to do. They want to be shown this is better to do. So when you can demonstrate by doing things, people may not believe what you say, but people see your action. Hey, you know what? He's going home every day on time. He doesn't have as many bugs. What is it that he does? And you're quietly sitting there and doing. Success is contagious. Success is contagious, right? If you tell me you will be better, I'll be better, I'm not willing to believe it. But I see you successful. You're releasing code with better quality. You're going home, you're not fighting those bugs in the evening. What is it that you do that I'm not doing? I want to come and see what you do. There is nothing as convincing an organization as success is. You know, people come to me and say, how do you convince your boss this is a better way to do? You go and say, I got this wonderful idea, I want to do it. Sit down, go back to your desk, get the work done. If they look at you and say you're successful, they come back and say, what can we do to support you? How can we facilitate you? And I've seen this personally in organizations. When you are successful, people want to do everything to make you successful. They're like, clear the way, stay out of this way, he's succeeding. And there is absolutely nothing better to convince people than your own success. So go do stuff you believe in. Succeed with it. People take note of it and say, let's go do this. There is no better way, in my opinion, than actually succeeding.
Could you tell us examples for how you yourself have become successful in areas when what were the techniques that you tried? What were the as I previously mentioned, for example, Agile or functional programming? Can you tell us that what you found in these that made you or may make other people successful?
I think the first is we should be willing to fail early, fail often. Anything you do, just look back at the life, anything you do. The first time you started having a meal, mom had to feed us, an adult had to feed us. We learned eating. First time you started riding a bicycle, you fell, you had bruise on your knees, your elbows, and then you learned to start riding a bike. First time you started driving a car, that was the scariest day for the city when I started driving my car, right? The first day you gather the courage to go ask the girl out. We have to try. We improve by doing stuff over and over and over. The sooner we do, the sooner we try, the sooner we fail, we get better at it. We get convinced that this is better. The second thing I'm going to say is, the worst way to do anything is to ask for permission. I've learned this lesson the hard way. I went to my boss one day and said, I've got this great idea. I want to do this. And my boss said, sit down, go back to your desk and do it. Do this work. We don't have time for this stuff. Sorry, we got other things to do. And I realized this is so important to do. But why wouldn't people want to change the way they do things, right? So then I started, in my own, frame of circle of influence, right? There are things I can change. I don't need permission for other people to tell me. Who needs to tell me that I need to write better quality code? Nobody. Who tells me that I have to create better quality variable names? Nobody. I can create better variable names. I can create better function names. I can write automated tests in my own piece of code. I can write smaller methods. So you start changing things in your sphere of change, influence of change. And when you start doing it, other people begin to take note of it when you succeed. And then they say, hey, that's much better, I want to do it. So one of the best way to effect change is to start actually doing it. It gives you the opportunity to experiment. It gives the opportunity to try things out. Not everything I do is going to succeed. Not everything I try is going to succeed.
That's okay.
But that's okay, right? It's perfectly okay. And then you figure out your way around because you have tried so many different things. So my first recommendation is, go try it. You go to your user group. You go to a particular presentation. You go to a conference. And you hear something new. You hear something different. It may not have to be new, but something different, something they've tried. You tell yourselves, I'm going to try it. It could be a small project, could be a home project, could be a side project, but I'm going to try it. Because when I do, I fail. Then I learn. Then I get better. Then I've raised my level of competency because I've tried it. Everything we do comes from that trying. There are some wonderful people, very, very capable people, and often they don't succeed not because they're not smart. It's because they never tried. Right? I think that's why it's important to go try these ideas and then influence. That's why it's important to do this.
They don't succeed because they haven't failed enough times.
Yeah. Edison said, I've not, failed. I only tried 1,000 times or 10,000 times. That's very important.
In what direction do you think this is slightly related but slightly also unrelated. In what direction do you think the industry is heading towards? So what other promising methodologies or methodologies do you see that make the life of the developer easier, or think that if you take them into account, then production code and communication will get better?
Almost everything, every change in technology has been caused by business change. You know, as technical people, we can sit down and say, oh, we are technical people. We effect change. No, we don't. It's the business that drives us. Rightfully so. When did we adapt to object-oriented technology? When did we start adapting to things like Ajax or things like rich web? And we're seeing this change again. We're seeing big data. Companies want us to build responsive systems. So technology has to keep up with these demands. So our efforts in functional programming is driven by the market demand. Concurrency, responsiveness, right? More complex applications, more concurrent applications. So technology is there, but business drives technology. So where's the future heading? How do I know? Right?
I'm interested in your personal opinion.
I can't, because it's really hard. We don't know what the future is. Right now, we are seeing demands on big data. We're seeing demands from mobile devices. One thing I can certainly tell you is, the future is not going to be in desktops. The future is going to be not just in mobile devices. We're talking about embedded devices. You know, people are talking about wearable devices. Forget about watches. We're talking about nose ring and ear ring and tongue rings, sensors that's going to be communicating, right? So IoT is very powerful, but we haven't even realized what that is in terms of its magnitude. We're talking about nano devices, right? And I think that's where the explosion is. And we are just in the brink. This is a beautiful, beautiful time to be in the field, right? And you're looking at this explosion in front of us in terms of technology and adapting to these. I think the way we're going to do computing is very different in the future. The biggest hurdle for us is trying to frame the future with the limited knowledge we currently have. We're going to have leaps and bounds of changes we're going to do. The key is to abandon what is holding us back and start doing things that require us to change in the future. I think in the next 10 years, we're going to see things we have never even. You know, if you really look back, every 5 to 6 years to 7 years, we're looking at technology that did not exist. How could we suddenly say, in the next 20 years, we know exactly what we're going to do? The key is not to predict the future. No, to adapt to it. The biggest win is to adapt to the future, right? So it's like what Darwin said. Darwin did not say the fittest is not the one that survives. It's the most adaptable that survives. So as a developer, my success is not in predicting the future, because my chance of predicting is so low correctly. My success is in adapting to the future. It is to say, I don't care what the future is, but I'm going to be there to respond to it. So I don't want to predict the future. I want to adapt to the future. That's where my strength is, right? Because if I predict the future, I'm going to be very likely wrong. But if I'm saying I'm going to adapt, I'm going to prepare my mental muscle to be ready to the change, I can be there to receive the future when the future arrives, right? So the biggest way to win is not to predict the future, but to adapt to it. And that is why it's important to be able to adapt to that. Prepare yourself for the future, not by predicting it, but being adaptable. I think that's what is the most important.
Thank you, Venkat.
Pleasure, thanks for having me.
Because we had multi-core, we couldn't build faster chips, so we built more chips. which resulted in a way for a need for functional programming. But now, for example, Google is progressing very quickly with all kinds of AI for problems that were solvable also by algorithms, or even ones that were never thought to be solvable. And the AIs are solving those. What do you think? How do you think AI will change what a programmer means? Will users become programmers just by specifying what they want?
I don't think so. I don't think, at least I cannot see that happen, because that was predicted 40 years ago.
Yeah, I know.
But it never happened.
Yeah.
Not yet. But will there be a time when systems can create software, systems can create themselves? Sure, eventually. But I don't think we are there yet. I think we are merely scratching the surface. This is one of the things I think we should really keep in mind is our field is very nascent compared to a lot of other fields. We've been doing medicine for centuries. We've been building construction for centuries. We've been doing software for what, 50 years? How could we suddenly say, we got this, we got figured this out? Maybe 200, 300 years later, somebody would come and say, what were you guys thinking back then?
Yeah.
You knew very little and you were so satisfied about this, right? So I think it's important to give ourselves the time to learn, to make mistakes. I think AI, machine learning, all of these are phenomenal in terms of where they're going to take us. But the short answer is, we don't have a clue what that is.
Yeah, I'm interested in your intuition. How do you think that will change programming as a profession?
I don't know, honestly.
You don't have to. I'm just. What do you get? What is your guess?
It's not a guess. It's like a wow, right? It is just even imagining what it is going to be. It would be naive of me to tell you, here's my assumption, right? It is to surrender and say, the future is going to be future. And I'm at awe about the future, right? It is naive for me to say, I mean, did we think of self-driving cars 20 years ago? 30 years ago?
I think we did.
We imagined it.
Yeah, exactly.
But there's no much close to what we're doing now. Did we think of programming and computing the way it is today? Not at all. It is amazing. The future is just amazing. And to draw the future with the limitations of my past is the worst fallacy. It is to really is to say, are these things going to make a big difference? I think it is going to. But how could you, it's naive of me to say, I'm going to put the box and tell you how the future is based on my limitations. I don't think I even am qualified to even do that.
I'm just interested in your imagination.
My imagination is too weak.
Okay, thank you.
Yeah.